Okay, good morning class. So today we're looking at congruency and similarity. However, we're looking at example exercise 2 which deals with similarity. Okay. That's the example 2. Exercise. Okay. Here's my book. Right, so we have this completed exercise 1 already. Right, so in exercise 2 we are told, in the first part, decide whether the following pairs of triangles are congruent or not. Write the triangle in the right order and give the appropriate condition for congruency. So they didn't ask us to prove that the triangles are congruent. And the other gave us an example as well. Okay, we'll just put here. This is exercise 2. Number 1 to 10. Okay. This on page 148, 149. Okay. The other gave us an example of what they want. As you can see here, you got AB equals x, y, z, B, C is equal to zx, and angle B is equal to angle z. So you got two lengths and included angle. And what case of congruency is that? Side, angle, side. So what we do is you say ABC is congruent to triangle YZX. So if you had gone and said, okay, you maybe went with ACB, so then you're going to say it's congruent to triangle. So if you've got A going through the unmarked length and then through the 2, then this has to be Y, X, Z, side angles. Can you see that, people? If you had gone with CBA, then this would have been triangle X, Z, Y. Can you see that, people? So your sides, it doesn't matter where you start. However, when we're going with the other triangle, it must be in the right order as well, the corresponding sides. Alright, you guys understand? Okay, so part of your homework was for you to have completed this 10 sums, no? That's correct? Right, so let's do number 1. Look at number 1. What do we notice? Okay, there are 4 cases for congruency. What are the cases? Side, side, side. Side, angle, side. Angle, angle, side. RHS. Okay. When we use that one, it must be the included angle. Not so. So if we look here, what can we say? PR is equal to BC. Also, QR is equal to AC. Also, QP is equal to AB. So are they congruent? Yes. So therefore triangle PQR is congruent to triangle. So here we go. PQR going through the 3, 2, 1. So I must follow the same route. Through the 3, 2, 1. So it's going to be BAC. And what account of congruency is that? Side, side, side. Why side, side, side? Because I have indicated 3 sides are equal. Will you guys understand? Is there any confusion there? No. Okay. Number 2. Let's pull this down here. Right, for number 2, What do we notice? Both are 90. Did we use the hypotenuse? The hypotenuse is always opposite the 90. Have you used the hypotenuse? Yes, the hypotenuse are equal. And BA is equal to PQ. Are these two triangles congruent? Yes. On what condition is this congruent? Sorry? Side angle side. But when we use this, it must be the side angle side. Side angle side. It must be the included angle. There you have two sides, that is the included angle. The angle between the two known sides. Is that what we have? No. So is it side angle side? No. We use that right angle, not so. Did we use its hypotenuse? Yes or no? Yes. So this is an example of RHS. Okay. So make a note there that there has to be an included angle. So therefore triangle ABC, they go A, going through the 1 to the 90 and then through the unmarked side. Is congruent to triangle. Through the 1, going to the 90, so I'm not going that direction, I'm going this direction. Through the 1 to the 90, through the unmarked side. So it's PQ, R. And what account of congruency is this? RH. Okay. Let's look at number 3. Number 3. Right. You see AB is equal to PR, which is correct. Not so? Then we have an angle here. C is equal to P. Then we have B is equal to Q. Are the two triangles congruent? Yes, you all agree with that, no? Who agrees? Put up your hand. If you're not going to put up your hand, I'm going to ask you why not. Okay, Chrissy, why not? Because yes, good start.
AB, the side of AB isn't the same as the side of PR.
AB is equal to PR. That means to say that that length there, that one thing there, and you see is 1 length. That means to say that this length is equal to that length. That's basically what it means. Doesn't it look equal? You say it's not looking equal, but with that, that is equal. Okay?
I'm saying that Q isn't opposite.
There we go. That is what I'm looking for. You see that this length is opposite the angle marked 2 arcs. Can you see that? And this here, that stroke is opposite the angle marked 1 arc. Can you see that, people? So, are these two triangles congruent? No. Why? Because it doesn't fit any of these conditions. Remember that the corresponding sides and the corresponding angles must be equal. You guys understand? Okay. So say for argument's sake we went and we said, but in the order won't also be right. Let's say it was ABC is congruent to triangle. So A was unmarked. So it's R is unmarked. Then I went with B, which is 1 arc. So it's Q. And then C, which is 2 arcs, is going to be P. If that is the case, people, then AB is equal to PQ, PR. So AB is equal to PR. Oh, so it's RQ. Can you see it's not equal? You see that, people? So furthermore, it's proven that it's not congruent. So, in turn, we just say that triangle ABC is not congruent to triangle RQP. Okay. Is the order then important if it's not congruent? No. It's only important when it is congruent. Okay. Let's make a note there. Why it is not congruent? Because the side is not opposite the corresponding angle in the two triangles. Okay. I think there's two such cases in this exercise. Look at number 4. So let me take this off here. Look at number 4. Is Km equal to PO? Yes. Is KL equal to PR? Yes. It's given. Not so. And we have angle K and angle P, which is the included angle. Can you see that, people? Two lengths and an included angle. What does included mean? The known two sides are where the angle is wedged between the two known sides. Question is, are these two triangles congruent? Are the two triangles congruent? Yes. On what account? Side? Angle side. You see that, people? So we say yes, therefore triangle. So if I go M, KLM is congruent to triangle. So if you go K, then where must I start in this triangle? P. L, I'm going through the side marked 2 strokes. So where must I move from P? To O or to R? R. O. And what account of congruency is this? Or what condition? Side angle side. Yes. Sorry?
Can you say LKM?
So it's U into it, therefore triangle LKM. Yes, you can. However, if you're going to go L, K. So where are you going to start? R. R. P. O. Which is correct. And what account is that? Correct, absolutely. Alright. Because I look here. You got L, you're going through the 2 strokes to the known angle and through the 1 stroke. So it's 2 strokes to the known angle to the 1 stroke, which is correct. So again, the order depends, whatever you got there, the order must just correspond. Okay. Anybody else that's confused? Number 5. Number 5. XY is equal to? XY is equal to? D. Angle Y is equal to angle? D. YZ is equal to? D. Are the two triangles congruent? Yes. On what account of congruency are they equal? Side, angle side. Why not RHS? You'll be using a right angle. So why not RHS? We're not using the hypotenuse. Or the hypotenuse is not known to us that they are equal. You guys understand? So what are we saying? Therefore, triangle X, Y, Z is congruent to triangle. So I start X, Y, Z. It's congruent to triangle. Sorry? E, EF. And we said it's going to be side angle. Side. So you see here, between X to Y, D to F. Going through the one mark, then to the 90, then to the side with marked with 2 stripes. Okay. See any confusion there? Number 6. Number 6. MR is equal to GH. MP is equal to, sorry, MP is equal to FG, yes. Angle P is equal to? Are the two triangles congruent? Who says yes? Why not, Pumla? You're scared? Are you scared of me? In future, I won't take your lunch anymore. Okay, I won't take your lunch off you. Awesome. Okay, why do you say it's not congruent? You think it's congruent? Who says it's not congruent? Pumla, on what account of congruency is that congruent? Ah. Sorry? It's not congruent. Why not?
I was going to say it would be side angle side, but there's no angle that we were able.
Here we go. You see, she's going to say side angle side, but angle M is not known to us. It is not the included angle. Can you see that, people? So therefore, triangle MRP is not congruent. Does order matter now? No. HGF. Why? Because not enough information given. So we can make the note that it is not the included angle. Okay. The learner always make that mistake. Okay. Sometimes he knows what's going on. However, he gets confused or he slips his mind about SAS, side angle side, that it must be the included angle. Okay. We are number 7 now. Number 7. AB is equal to which angle? AB is equal to which length? AD. BC is equal to which length? CD. What else can we say about the two triangles? AC is a common side. Are the two triangles congruent? Yes. What account of congruency is this? Side, side, side. That was an easy one. What type of shape is this? Therefore, triangle ABC is congruent to triangle. It's ABC. What's the order? ADC. And the count is side. What type of shape is this? It's a kite. What makes it a kite? What makes it a kite? Two pairs of adjacent sides, not opposite. Two pairs of adjacent sides are equal. Didn't we do quads in grade 8? Sound like you guys had a good holiday, no? You forgot all these things. Next year, you guys shouldn't take a December holiday. Rule number 8. Let's look at number 8. You got two triangles. Question here. PRQ and QSR. Are the two triangles congruent? Remember now this is Q, R, P. That is marked 2 arcs. This is 1 arc, 2 arcs. X, I'm missing some algebra there. Q, R, S. So what do we know? We know that R, angle R of this triangle is equal to Q of that triangle, not so. Do we know that angle P of this triangle is equal to angle S of that triangle? It's given, eh? So what did we say yesterday about congruency? You must use at least one side. Do we have at least one side that is equal? Which is the side? QR or RQ. As you can see, it's a common side. It's in both triangles there. So what case of congruency is this? Angle? Angle side. Can you see that, people? So we say therefore triangle QPR is congruent to triangle. So if we start at QPR, then what must it be here? Sorry? R is Q. Why? Our favorite, no? Angle. So. Easy. Not too easy. Let's go with the next one. Number 9. For number 9, I think it's easy if we take it apart, not so. Find it easier if we take it apart. Whoops. That's not the part. Right, so this is going to be B, A, C. And this here, B, C, D. Are the two triangles congruent? Why you say no, Michael? Rudolph, you say Why? AB is equal to what? Easy. That's given. Angle A is equal to? Angle DY is given 90. Not so. So we just need one side or one angle. Yes? It's a common side. Is BC not in both triangles? It's in both triangles. So what case of congruency is that? Why RHS? I'm using the right hand, I'm using the hypotenuse, and I'm using a sine. That's the case of RHS. So therefore, triangle ABC is congruent to triangle. So if I go A, B, C, what must the order here be? D, C, B. Then say I go 90 through the 2 arcs and the hypotenuse. 90 through 2 arcs, hypotenuse. So it's going to be DCB. And we said it's going to be RH. Okay. Is it a nice one? Yeah, then again all the sums are nice, ne? Number 10. Okay, so here we got two triangles, ABC and DCE. Right, what do we know? Angle D, angle B is, angle A is equal to angle E, yes. So we need one. We need a side. Do we have a side? AC is equal to C. I think this was the easiest of the lot. Yes? Sorry? A is common. What does common mean? It is in both triangles. It's the same length in both. The length is used twice. But this length is not used twice. Part of that length is used in this triangle, and part of the length is used in that triangle. So I can't say AE is a common side. Okay? So people, are the two triangles congruent? Yes. Let's check here. Opposite that, the one stroke, we have two arcs. Can you see here? Opposite one stroke, we have two arcs. So they are congruent. So therefore, triangle ABC is congruent to triangle. So you start at A, one arc. So we must go with E, B is, B corresponds with D, and then C. And what the count of congruency? Angle, angle. Okay. People, you guys understand? Okay, we're spending a lot of time on this, no? So I'm going to go into exercise 3. I'm going to stop this video at this point.